Okay, let's continue with the type of constitutional isomers. There are 3 types of constitutional isomers. So chain, from the name chain, we know this one is referred in Bahasa, we call their rantai. So this rantai, basically we are focused on the carbon chain. Okay, and then we want to focus on the longest carbon chain. Are they similar or no? So normally, if it is for chain isomer, the longest carbon chains will be different, but the position of the functional group and also the functional group will be similar. Okay, so from the word positional, so we understand is from the word kedudukan. So from here we understand if they are positional isomers, normally they will have same longest carbon chain, but the functional group or the substituent will be at different position, and both of them will be have same functional group. So the last one is the functional group isomerism. So means that they will have same longest carbon chain and the position of the functional group will be same, and then they have different functional group. So the conclusion will be here is they will have all these, they have one difference and two similarities. Okay. So based on the name, the name is chain isomerism, so the longest carbon chain is different. The other two position and functional group are similar. So now we try to look at the chain isomerism. So look at the example given here. Again, like just now we say they will have different carbon skeleton or the carbon chain. Okay, but they will have same position and type of functional group. So for example, the first example here, the longest carbon chain from the left hand side is 1, 2, 3, 4, and 5 carbon. But while the other one is 1, 2, 3, 4. But in total, they have 5 carbon as well. 3 times 3, 9, plus 1, 10, and then plus 2, 12, H12. Okay, which is similar. This one we have 5 carbon, 3 plus 3, 6, plus 2 times 3, 6, so H12. So they are isomers because they have same molecular formula, but at the same time, they have different structure. So this one is chain isomerism. So next we look at the positional isomerism. Based on the definition here, they will have different in position, but they will have same carbon skeleton. So for example, this one, they have 3 long carbon in the carbon chain. This one as well, 3 carbon in the carbon chain. But the position, which is the halogen, this one we consider they are attached at the first carbon from the right, and this chlorine, another structure, is the second carbon. So they have different position. So if I name this one will name as 1-chloropropane. And this one will become 2-chloropropane. Okay. For another example, you can see the carbon-carbon double bond is in between carbon 1 and carbon 2. While the other one is between carbon 2 and 3. And both of these structures have 4 carbon. So that's why in general, they have same molecular formula, but different structural formula due to different functional group. Due to different position of the functional group. Okay, the next one is the substituent. Beside from the functional group, the position of the substituent can be different. So this one we consider the substituent is at carbon 1 and carbon 2. And then this one is carbon 1 and carbon 3. And this one is carbon 1 and carbon 4. So 3 of them are isomer because the position of the substitute are at different position. Last type of constitutional isomers is the functional group isomerism. So in general, we try to get the structure, get the general formula. If they fulfill these 4 general formula, they have the possibility to show different functional group. So if the general formula is CnH2n plus 2O, so it can be alcohol. So alcohol will have the hydroxyl group, and ether will have the alkoxy group. In between, the oxygen is between carbon. So if for the CnH2nO, it will be aldehyde and ketone. So for aldehyde, we have C double bond O, and then carbon always have 4 bonds. Another 2 bonds, one must be bonded to hydrogen, and then another one generally are alkyl group or bonded to carbon. So if ketone will be C double bond, but left hand side and right hand side both will be attached to the carbon. So CnH2nO2, this is for carboxylic acid and ester. The functional group of carboxylic acid always will have C double bond O, OH, while for the ester is the C double bond O, O, and then attached to C. Okay, so the last one is the alkene. So alkene means that always have carbon-carbon double bond, while cycloalkane normally have the shape which is like a triangle, square, or pentagon. Okay, so all these are considered as cycloalkane. Okay, so in next video, I will share with you how we're going to determine what is the type of constitutional isomerism.